So now we are discussing a problem that you generally come across when you appear in an exam, and sometimes it may also be asked in an interview, that is beam carrying a load with a bracket at any point uh, on its span. So this is the case. This is beam simply supported at the two ends. The reactions R1 R2, its length is given. So here we have a bracket and the load is applied like this. So I'm taking an example uh, from the book of Ryder, G.H. Ryder, very good book. A 20 kilonewton load is acting here, and this is a bracket. This distance is 1 meter, and distance of this where the bracket is fixed from this side it is 6 meters, and here it is 2 meters. So you have to draw the shear force and the bending moment diagram for this arrangement. So now this bracket, what does it do? If I take this separately, now what I do here is apply the same load like this, 20 kilonewton, 20 kilonewton. This is called transfer of a load. So what this load is doing here, this cancels this, so there is no problem with this arrangement. Now this load and this load, they are making a couple here. So at this point we have a couple along with this load which is left. So you can show it like this, couple or a moment like this, and 20 kilonewton, and this is 1 meter, so 20 into 1, 20 kilonewton meter. So you can show the arrangement like this. So it is having a downward load 20 kilonewton along with a moment 20 kilonewton meter and the reactions. Now we have changed this to this. Now we have to find the reactions and A and B. Taking the moment about end A, so we can write moment of this in this direction clockwise. Let us take this as negative, minus 20 into 6, and this is already having this moment 20 kilonewton meter about this is in opposite direction, so let us take this as positive, and moment of R2 is also positive, R2 into 8 equal to 0. So this gives R2 is 100 divided by 8, 12.5 Newton. Positive, so it means acting in upward direction. We take upward as positive. And R1 plus R2 is equal to 20, net upward load equal to net downward. So R1 is also positive 7.5 kilonewton in upward direction. So now let us draw the shear force diagram. Fx is taking a section here, distance x, R1 which is positive 7.5 kilonewton, positive, so up to this section the shear force diagram is positive. Now for this is for x between 0 to 6, and for x between 6 to 8 the shear force is R1 minus 20, so it is equal to 7.5 minus 12, minus 12.5, negative of the reaction at the other end, so it is like this, minus 12.5 kilonewton. And is like this. You can see the change here, plus 7.5 minus 12.5. So this minus this equal to 20 kilonewton at this point, equal to the point load acting. Now let us draw the BMD. Mx is at this section R1 into x, that is equal to 7.5x for x between 0 to 6. So x equal to 0, bending moment is 0. This is the equation of a straight line. X equal to 6, 6 into 7.5, 45 kilonewton meter. This is 45 kilonewton meter. And for the remaining part, you can show the diagram from this side also, make calculations, or you can write it like this. For x between 6 to 8, the bending moment is moment of this load R1 into x. Now x is here, this section is here, minus 20 into x minus, if you take the section here, this is the distance x. So about this is having a moment in this direction, negative moment, this is having positive moment. So this distance is x minus 6. And 20 kilonewton meter is also a negative moment about this. So minus 20. So you can calculate the value by putting x equal to 6. So at x equal to 6, mx is 7.5 into 6 minus 20, as this term is 0. If you have x less than 6, then this is immaterial, this will be 0. This is applicable only for x equal to 6 or x is greater than 6. So you see that here there is a change in the moment at the same point. So 45 minus 20, 25 kilonewton meter. So here it is 25. It drops to 25 from 45. See the change, 45 minus 25 is equal to this 20 kilonewton meter, and then a straight line. Or you can draw it to save the time from this side also. If I take a section here from this end at a distance say this capital X, in that case mx, see the change here, it is capital X, is equal to moment of only one load on this side, R2 into x. So R2 is 12.5x. So at x equal to 0, now we are measuring from this side, x equal to 0, it is 0, bending moment is 0. This is the equation of a straight line. And at x equal to 2, this is 12.5 into 2, 25. So you can draw it like this, the easier way to draw this. So this is a very important question which appears in the exam.